In this video, I'll be summarizing Open Up 7th Grade Unit 1, Lesson 10, Changing Scales and Scale Drawings. So today's goals. 1. Given a scale drawing, I can create another scale drawing that shows the same thing at a different scale. And 2. I can use a scale drawing to find the actual areas. Today in class, you looked at the same plot, different drawing. Your groups reproduced a map of the triangular piece of land in Philadelphia, but you all used different scales. When all was said and done, you had triangles that looked like the ones shown below. So I want you to think to yourself, how does that change in the scale influence the size of the drawings? For example, how do the lengths of the scale drawing where 1 centimeter represents 5 meters compared to the lengths of the drawing where 1 centimeter represents 15 meters? Thinking about which one's bigger, how much bigger, etc. So, because 1 centimeter to 5 meters is equivalent to 3 centimeters to 15 meters when you scale each of those numbers by a scale factor of 3, you're going to get that the lengths of this one, the 1 centimeter to 5 meter representation, are 3 times as long as that 1 centimeter to 15 meter representation. And you can check that in the images below. Right. If you think about areas, how does the area of these scale drawings compare? So we'll still look at the 1 centimeter to 5 meters and the 1 centimeter to 15 meters. All right. You should notice that because the side lengths of this first drawing are 3 times as long, the area is 9 times as large. Remember that scale factor squared shows you your area factor, and 3 times 3 is 9. If you're still a little hesitant about this topic, you might want to prove it to yourself by finding the area of each shape and see that it really is 9 times as large. All right, so to wrap that up, as the number of meters represented by 1 centimeter increases, the lengths in the scale drawing decrease. And the area will also decrease, but it decreases by the square of the factor for the lengths. So sometimes we have a scale drawing and we want to reproduce it at a different scale. Remember, we talked about Beaver Stadium last week, and the scale drawings can be different sizes, but the actual object in real life, it doesn't actually change. So if you can figure out how big it is in real life, you can use the actual lengths and your scale to calculate your corresponding lengths. I consider this first option the safer way to do it. Less mistakes usually happen this way. But 2, you could also just scale one scale drawing right to another by looking at the factor that it changes by. I would consider this the more efficient way. As long as you're really careful about if it's going to get bigger or larger, bigger or smaller, then that would be a great way to do it as well. All right, last question to ask yourself. Suppose you have a map that uses the scale 1 inch to 200 feet. And then you draw a new map of the same place and you use the scale 1 inch to 20 feet. How does your new map compare to your original map? Please think about both the lengths and the areas. All right, I hope you answered. The lengths of the new map will be 10 times as long and the area will be 100 times as large. All right, go ahead and look at your daily goals and just make sure that you feel like you can do them. And if not, it's a great time to ask for help.